Good evening, everyone. My name is Sam Nasser, and this is the Cleveland C# VB.NET user group. A little bit about the group. We meet every month, typically every fourth Thursday. However, due to the Thanksgiving weekend, we're going to be meeting this Monday evening. The meetings are always free of charge and open to the public, and we cover a variety of topics related to .NET. You can find meeting information posted at meetup.com at the link listed at the bottom of the slide. I'd like to give a big thank you to our sponsors, PostSharp and DevExpress, for the post-meeting prizes that will be given out using the evaluation forms, the .NET Foundation for sponsoring the meetup space, and NIS Technologies for sponsoring recording services and the meeting space. A special offer from Manning.com. You have a selection of books that are available at 35% off. The discount code is MTPCLEC21, and that will be presented in chat in just a little bit, as well as the URL for purchasing the books. Some general information. First and foremost, please keep in mind participation is encouraged, and the only stupid question is the one not being asked. So feel free to jump in at any point in time with a question or comment. However, when not speaking, kindly ask you to mute your microphones just to avoid any background noise. And we always like to keep it casual. So again, don't wait for when the speaker asks for questions, but feel free to jump in either verbally or in chat. And lastly, the presentation is being recorded and will be posted on YouTube within a few short days. So that brings us to tonight's feature presentation, and that is Docker with .NET Apps with Joe Brinkman. Joe is a director of consulting at Improving. He has 30 plus years of development experience and leadership. He's also the co-founder and vice president at DotNetNuke, which is the largest open source CMS system. And when not doing all that, he's also a blogger, author, and a speaker at various conferences. And so with that, let me turn it over to Joe.
Thanks, Sam. Okay, so what are we going to be talking about today? We're going to be going over Docker 101. So a lot of what I talk about is, this is from a talk I've given on multiple occasions, most recently in the context of Node apps. Today we're going to be talking about it as it relates to .NET. And really much of this talk doesn't really matter what the underlying language is or technology is. This is really about Docker itself and how to use Docker and how to leverage that with your applications and why you want to use Docker and why that matters to you. Okay, so I'm going to be looking over at my other monitor, so if I'm not looking at everyone, understand that my content is mostly on the other monitors. So today what I want to talk about, so a little bit about me. As Sam said, let me see if I can get my PowerPoint under control. So I am currently a director of consulting at Improving. I've been here for about 3 years. As Sam mentioned, a co-founder of DNN, but I've also done a lot of other architect and cloud solution development, and in fact did most of the R&D for been working in and out of the cloud for the last 10 years. So this is really kind of native to where the cloud is today and where many things in the desktop arena are going. With that, what we're going to look at today is we're going to talk a little bit about why containers are a good thing, why they were created, and what purpose do they serve. We'll talk a little bit about what containers are and try to give you some analogies to better understand what containers are, why they're different than virtual machines, why containers seem to be taking over where virtual machines used to be everywhere. Now you're seeing more and more containers come into the picture. I'm going to be spending a lot of time on demos. We'll walk through a lot of examples of how to use containers and how to get started with containers and get all the way up to some advanced scenarios that you'll want to explore on your own, or this will be a starting point, a leaping off point for your further exploration, and then we'll go through a quick wrap up. Okay. So with that, when we talk about containers, the first thing we have to understand is why were containers created? Like, what problem do they solve, right? We've all built apps before, or presumably most of us have. And the question is, what is it that the container provides? Because if you think about typical app, it's not just code. You often have a database. You often have some sort of a queue, a little less often than the database, but you might have a queue or a message bus or a service bus or something like that. You might have caching involved. It might be an external cache, like a Redis cache. You might have a client application that attaches to your app. So think about in the context of web development and where web development is going lately. You typically have a server-side app, and you have some sort of a spa that runs on the front end as a client. But this could be desktop to back-end server, any number of front-end clients connecting to your application, right? You might have analytics service that you need to spin up. Now think about how that looks in development, right? Often we're developing on our local desktop. We might have 3 or 4 of these apps spin up in our local desktop environment. We might have some services that we're running remotely. Maybe our analytics is going to something like Azure Insights, or it may be going to some other logging service like Splunk or something else, right? But we also have QA environments, and often one of the challenges we have is that you give something to QA and it's like, oh, I don't have that data, or oh, how do I get this configured so that it runs in the QA environment? How can I stand up and tear down this thing to make sure that every time we go and we're doing a QA run that we have a clean run, right? That we're not leaving over configuration or data from previous runs that are impacting our testing. How do we make sure that what goes into production is the same thing that the devs were running, which is the same thing that QA was running, right? These environments may look different from a hardware perspective, right? I might apply more resources in the production environment, but they shouldn't be different in the way the application runs. We want to be as close to production in our dev environment as we can be, and in our QA environment for sure. We want to be as close to production, and that means making sure that the configurations kind of match in those environments, and that how everything is set up is the same in those environments. And then finally, what happens if we take our app and now we want to move it to the cloud? How do we do that, right? And then how do we make sure that all these environments, when the developers say, oh, we need to add this new feature and there's this new service that needs to be stood up in the environments, how do we make sure that that gets out to all of these different environments and that we don't have minor configuration differences that might cause differences in application behavior, right? This has historically been a very big challenge in the application development space. And we have in the past solved this problem in part by using virtual machines, right? We can encapsulate a lot of things inside a virtual machine and pass that to different environments, and that would allow us to effectively have a single packaged entity of configuration, data, and application, right? Which is the 3 parts that you need in order to have an application up and running. And all 3 of those parts need to be in every one of these environments and be the same or similar in all of these environments. And that's really the challenge that we were facing in the early 2000s. And VMs were just not quite solving the problem the way that people wanted them to. So there was a realization that we needed something like VMs that was a container for our application. If you think about in the physical world, right, this is a problem that has gone back thousands and thousands of years. How do I take different objects different sizes and shapes and weights and everything. And how do I transport them? How do I move them from one place to another? And the way we've done that in the physical world is through this concept of a shipping container. A shipping container is a set-sized object, container, box, if you will, that allows us to put things inside of any size and shape. And we can take that container, and no matter what country we go to, no matter what port we go to, we know how to handle. We have tools and everything that can handle those standard container sizes, right? And we can take those same containers, we can put them on the back of a train and ship them across country where we can't get to with physical ships. We can take them off of those trains, put them on trucks for that last couple of miles to the final destination of our content, right? This is the vision that they had when they were creating containers. How do I take this application and make it very portable and make sure that the configuration and everything goes along with the application, right? So the other part, when we look at Docker, what it is, it's really a portable runtime environment. It's self-contained, it's pre-configured, it's isolated. We'll talk about that more in a minute. And it can be fully automated. In other words, I can completely automate creating containers, spinning containers up, tearing them down, and doing a lot of other interesting things with containers because of the way that Docker is fundamentally built. The availability. Today, Docker and containers, and I use Docker generically. There are a couple of different competitors to Docker, but for the most part, you can think of Docker. Docker is a implementation of what is now a standardized containerization capability. And that's available on Linux, Mac, Windows, even Raspberry Pi, which runs Linux, but is powerful enough to be able to run Docker on those Raspberry Pis. And that means that basically Docker is available everywhere we want to be able to run workloads, because if you can run it on Linux or you can run it on Windows, then that means you can probably run it in the cloud. And in fact, you can run Linux in every major cloud provider today, have native Docker implementations, and another implementation called Kubernetes, which is really just how do I scale up a single container to dozens and dozens or hundreds or thousands of instances of container and manage all of that. Okay. So containers, you can think of containers as being this duality, right? There's really two sides to containers. If you think about physical containers, there is this view of containers of how do I manage these things? How do I move these things around? How do I treat this as one atomic package that I can create and distribute and get to where I need it to go? And we create tools that enable us to think of containers in that aspect. And then we have what is typically a developer view of containers, or someone who is shipping content. How can I lay things out inside that container? I'm still bounded by the size and shape and distribution of that container, but inside that container, I'm free to do almost anything I want, right? And so when we think about Docker, and we think about Docker containers, we have this same view, right? We have a bunch of tools that are created to allow us to manage Docker containers, and then we have a bunch of tools that allow us to define what it is that goes inside of that Docker container and how all of that is laid out. And that's the part that really is of most interest to developers. The ops view is one as you move into DevOps and start doing stuff with distributed workloads and scaling workloads, that you'll start to get more involved in that side of the Docker world. Today, for our purposes, we're mostly going to be worried about, as a developer, how do I get things in there and how do I start using. So why Docker? Why couldn't we just continue to use containers? What is the difference between the two, and what real advantages does Docker provide for us? So if you think about virtual machines, we typically have a server, which is the physical hardware that our application runs on. It could be a PC, a laptop, could be a big server, could be something running up in the cloud. And then we'll have a host operating system, usually Windows, Linux, something like that. And then there is this hypervisor. It runs as part of the kernel of the host operating system and kind of in this space between the operating system and the server somewhat. And then on top of that, for every application, it will have its own guest operating system. It will have a copy of the binaries and libraries that it needs to run, and then we'll have the application itself. So every time I have another virtual machine, I have another guest OS, I have another set of binaries, I have another application, and those two applications are completely separate from each other. They don't share there's nothing shared between those two different virtual machines. And then I might have a third application, and if you think about application A and application B, maybe they have dependencies on the exact same libraries, but excuse me. But even though app A and app B share the same library references, they are in fact two separate copies of those libraries sitting on disk. App C can reference completely different set of binaries and libraries, right? That's different, and we consider all of those stacks of the application, the binaries, and the guest operating system to be a virtual machine. That's what defines a virtual machine. In the container world, it's a little bit different. We have the same server hardware, we have the same host operating system. We don't have a hypervisor though. We have a bunch of binaries and libraries that exist on disk, physically on disk, and an application. If we have an application B that references those exact same binaries and libraries, then there is a mechanism by which we can share that disk space for those binaries and libraries. We'll look at that. It's a little more complex than this diagram would indicate, but you can effectively share those across applications and still maintain isolation between application A and application B. And then if you have a third application that has different binaries and libraries, then it will get its own set and they will be completely separate and distinct from the binaries and libraries of app A and B. And the big difference here is that I don't have different guest OSs for each individual application in the Docker world, in the container world. I have just the one host OS, and then each library or each application then effectively sees itself as having complete access to the host OS. And then you have some Docker libraries, some Docker magic, if you will, that runs off to the side. We'll talk a little bit about what that does here in a few minutes. And then those are a container. Container is that app plus the binaries and libraries that app needs to run. And we'll look at how those are built up here in a second. Okay. So one of the big differences between the approach taken by virtual machines versus the approach taken by Docker is a virtual machine effectively fools that guest operating system and says, You have direct access to hardware, and we give you a abstraction of the underlying hardware at the software layer, or at the hypervisor layer actually, and we say this is what your hardware looks like to that VM. We do it a little bit differently in Docker, and we use process isolation and different isolation techniques within the core of the operating system. So there's no hypervisor involved in this case. In the basics, we'll talk about a caveat to that a little bit later. But in the Linux world and the Unix world, there is something called chroot, which is basically changed the root. Like you can define, instead of the root of your operating system being the root of your system drive, right? So typically we think of that as C:, right? Is the root of our drive. That's the root of everything the application sees. In the Linux world, when you do a chroot, you can effectively say, hey, process X, when you're running, I want you to only be limited to this directory and below. And in fact, any calls you make to the operating system, for all intents and purposes, the operating system doesn't know about anything outside of this directory. And in fact, when you see a chroot inside of a terminal or inside of a session, that session is now locked to that root space, and you can't really break out of that without tearing down the session and tearing down the process that exists, right? So this is isolation at the file system level. So it prevents you from accessing other files in other directories. You can think of this similar to the way that IIS behaves, in that it tries to provide isolation down to your application and block your application from accessing other drives or other locations outside of that application folder. chroot does something similar, only instead of an application level, it does it at the operating system level, at the kernel level. They also take advantage of something called namespaces, and namespaces allows the kernel to isolate resources at the kernel level. Again, these are very low level isolation techniques that are available inside the Linux root. And then finally, there is something called control groups, and these further limit and isolate your CPU, your memory, your network, things like that. So these are all isolation layers, and these are the core of what makes up Docker. There's some other stuff that goes on for coordinating this stuff, and there's some other similar capabilities that have been added to Windows to enable this capability within the Windows environment. But it all stems from these three main concepts that derive from the Linux environment.
Hey, Joe, I have a question for you.
Yeah, go ahead.
If you go back to the previous slide for just a second.
Yeah.
So as far as the control groups, the last bullet point on the bottom, does that mean I can limit how much CPU and memory that each container gets?
Yes. Yes. You have control over what they see themselves like, and this is enforced at the kernel level. There's a really good talk, and I think I have a reference to it in the resources, where they show code, and she builds up the speaker in that talk builds up an entire container, and it's literally like less than 50 lines of code to do the whole thing, to do all three levels of this, and she shows how that's doable just in a very simplistic way within a small environment on Linux.
Cool, thank you.
So yeah, it's It's a little more complex than what I'm showing it here, but in a nutshell, this is the heart of what a container is. Right? And one thing to note here when we talk about this, although these are isolation done at the container level, I want to be clear that these are not guaranteed security boundaries. And what I mean by that is a virtual machine, because it has its own internal operating system, is by the nature of VMs more secure than a container. A container still fundamentally is sharing the same network, the same CPU, memory, all of those things, and it's only up to the operating system to keep those things separate and distinct. Virtual machines, because of the way they're run and because you have another operating system sort of in between, and you have that hypervisor as well that runs sort of outside of your main operating system. Those allow you to get much greater security and control and separation between your virtual environments than you can do with containers. That doesn't mean containers are insecure. It just means on a spectrum, virtual machines allow greater degree of security. So that is something to keep in mind, and it's something that is repeated in the literature over and over again. So don't think of these completely as security isolation. There are ways to make it secure, but it's not. That's not the primary intention here. Okay. So containers are layered, and we're going to see this in action as we get into the demos. What that means is that every time as I'm building a container, and you'll see, like when I put the lamp in the corner, it basically creates a container and says, okay, I've got a container where the lamp is in the corner. And then I add my desk in, and it says, okay, now I have a container where the desk is in one location, the lamp is in a corner. And then you add a third thing in and a fourth thing in, and each one of those creates a new layer, and each layer builds upon previous layers. So you keep stacking up these layers. And if at any point someone says, hey, I need a container that has a lamp in the corner, but I'm not going to put a desk in and I'm not going to put all this other stuff in. Well, I can go back to that base image that had the lamp in the corner, and I can then build a new container based off of that base image. And I have all of those referenceable on disk that at any point I could fork off of effectively and create a new container that starts at that point and moves forward. And in fact, as you'll see when we're building these up, almost every container that I know of starts from some other container. I'm not even sure what a true container that starts from nothing would even look like. Typically, you'll start from a container that has some basics of a operating system, for lack of a better word. It's not truly an operating system, but it feels like it. So the last area that we're gonna get into for this is this place called a Docker Hub. So as you can imagine, if we can treat each of those layers, right, each of these individual things are potentially reusable, then it makes sense that I could have a hub where I could store common images that might be reusable. So if you think about everyone building a .NET Core application, well, if I want my application to be able to run on .NET Core, does that mean I have to start from a base-based Linux image, load .NET Core, load a bunch of other libraries in, and then finally load my application on top? The answer to that is no, because Microsoft and others have created images with .NET Core and the .NET SDK already running on them, and all you have to do is add your application on top, and now you have your own flavor of that container. But there's a lot of work that was done below your application to create that image. Okay, so that's really the foundation of what Docker is and how it can be useful to you. So with that, let me go ahead and we're going to pop out of here and let's drop into Visual Studio. So we're going to do the demo today. Now, I did this originally. These demos I've done 3 or 4 versions of. So the last one I did was in Node, and this one's going to be in C#. So I'm going to try to stick in C# as much as I can. There may be a spot, depending on how far we get, where I switch over to Node, but for the most part, I think we can do everything we want in C#. So the first thing we want to do is I'm going to just open up here. I've got probably way too many browser tabs open, but that's okay. We're going to go to Docker, and if you go here, and I definitely recommend if you're interested in it all at Docker, is go in here and go to the Get Started page. You'll have to download desktop Docker, and what that does is that is an application that's going to run on your local machine. It's going to run the Docker daemon for you, and it will help you manage and run your Docker image, right? So this is the first step. You're going to go here, download for your machine. Again, it's available for Mac, Windows, and Linux, and on the Mac, it's available for Intel and Apple chip. So pretty much any environment you're going to run on, and if you search, you can find the one for Raspberry Pi as well. And I know there's some that have been developed for mini mainframe operating systems as well, but these are the main ones. So go here, download, do the install. When you're done with that, you're going to end up with Docker for desktop, right? So what is Docker for desktop? So this is an application that allows me to manage all those images we talked about earlier. I'm going to delete some of these before we get to them. Manage containers. So containers are running versions of those images. So if you think about every image here, and I'm going to delete some of these because they're actually not needed anymore. We'll remove a couple of these. This also allows me to push, let's say I had an image that was exactly what I wanted, and I could go ahead and push that up to that Docker hub, as you see, and that would cover everything. And that would allow me to reuse that Docker image to create new containers. So when we talk about Docker, we talk about images and we talk about containers primarily. Okay. So once we've got Docker installed and Docker up and running, let's go ahead and go back into Visual Studio, and I can do just a Docker as my primary command. So this is when you install Docker Desktop, it's also going to install the CLI tools that you use for Docker. Docker Desktop is getting more and more advanced. There's more and more stuff that you can do directly in the desktop in the GUI. But if you run Docker, you're almost always going to end up back at a command line. So I just recommend you start at the command line. In places where the GUI makes it easy, then drop into the GUI. But for the most part, you're going to see there are lots of parameters to some of this stuff where the command line, you just kind of have to live there. So Docker run is our basic command for running an image. So if we have an image, we can say Docker run. -it means it's going to be interactive. In other words, I'm going to get something that I can interact with when this is done. We're going to do a --rm, which means remove this thing whenever I'm done with it. Oh wait, I'm looking at the wrong command. Sorry, that's later. We want disconnected, and we're going to use a port. We're going to map 8080 and Docker getting started. Sorry, this is what we want. So all this is saying is run this image. It's going to be a disconnected image. In other words, it's not going to tie up my terminal, and it's going to run on port 80. It's going to map my external port to an internal port running inside the container. So this has an application running inside that container, and we're going to punch a tiny little hole. Think of it like a firewall. We're gonna map a port from externally to internally. So I could do the same thing and say, hey, map my external and make this 8080, right? I could tell it this, and it would take. And now, if I hit localhost 8080, then it would do the same thing, right? Don't want to do that here. So we've got this up and running on port 80. So let's go back to our browser here. And we can just go to localhost. And now we're going to get the Docker getting started. So a couple things happened that you may not have seen here. Notice that when I ran this Docker run command, I get this really long string here. So let me just go ahead and do a Docker images here real quick. And if I look at this command, FAA1, if we look down here, why am I not seeing? Oh, because that's the Docker run. If we look down here, we'll see this getting started. This is the image that was used for starting this up. If I do a, I'm just going to drop out to the GUI to make this easier. If I come in here and I kill this getting started, container, right? So I've killed the container, so it's not running anymore. And I know that because I'm running Docker PS, which is list all those processes, all those Docker processes that are running. I don't have, oh, I do have another one that says FAA1. Why is that one still running? Docker mode force FAA1. So that should, now let's run that Docker PS again. We'll see now that one's gone, and that's fine. That's exactly what we want. So those are for processes, but my Docker images should still all be there. So I've still got my getting started is there, but it's not running as we see here. So there's no container, which is a running version of an instance, a running version of an image, right? So here's my images. There's Docker getting started, and then I have containers, which is nothing here, right? So that's exactly what I'm seeing on the command line. Is what I'm seeing in the other tool. And that getting started. So this is a lot of this demo, a lot of the samples. If you go through the getting started, you'll see very similar information. I try not to deviate too much there. There are some examples I use that are more specific, but for our purposes, that's fine. So that's really the basics, right? How do I get to my images? How do I see what processes I have running? How do I remove those images? And how do I remove those containers? So we did a Docker RM, so if I wanted to remove that image, let's say I do that Docker run again, right? and I have this running, a Docker RM is going to remove that. And really, I only need enough of this string, and this is true of everywhere in Docker where I'm doing something with IDs. Really, I just need to get enough of the string that it's unique. I could also use the actual process name here. So if I look, this process has an actual name that gets assigned. So that Frosty Darwin, I could do a Docker RM -force Frosty Darwin, and that would also remove that Docker image, Docker PS, and we see Frosty Darwin is gone, right? And so if I not only can I do that on the processes, but I can do that as well. Let's see, I want to get rid of this 157 Docker images dash Docker images RM 157, and that should get rid of this getting started container or image. Why did that not? Oh, that did. Oh, Docker image RM 157. Does that? No, that should be Docker images. If you ever run into problems, just go into the help. And why am I not seeing? I wonder if something changed there. Oh, there we go. It is Docker image. It's a weird one. 157. There we go. Okay, so it deleted. Notice it deleted this 157, which was my layer, which was the image that I had, and then it deleted a bunch of other things. So these are all those separate layers that make up that Docker 157, that getting started container. So now if I go back and I run that same command from earlier, right, it's going to say, hey, wait a minute, I don't have that locally. It's going to go out to Docker Hub, and it's going to pull down each of those individual layers, and then I can look at now my Docker images -a, and I can see now my getting started is back there at 157. It's exactly the same image that I had before, and so that's how I can manage my images, manage my containers, see what processes are running, all of that directly from the command line. Now I can do the same thing. I can do most of the same steps here on within the Docker desktop app, and a lot of this has been updated recently. It's very very different than the way it looked even a year ago. So that's the basics of managing images and containers. And so because all of that's command line driven, that means it can be part of your package.json. You can have commands in your package.json to say, hey, you know, run this container, right? Run whatever containers for my application. You can have ones that set all of that up, but you probably don't want to go through and have to do all of these commands all of the time. But let's talk about what it takes to actually build a container. So in order to do that here, I'm going to go through and let's get back into my Docker. Okay, so all I've got here is a get ignore and a readme file. There's really nothing in this project to speak of at the moment. And so what I want to do is I'm going to do, so I've got .NET 7 installed on here. Right, so I'm just going to use, and most of this should be compatible with previous versions of .NET for several iterations now, at least as far back as .NET 3, I believe, or .NET Core 3. So we're going to do .NET Core. I am running on a Mac. Almost all of this is exactly the same as what you would do on Windows. You can use Visual Studio to create your project. That's fine. I'm going to create one based off the Web API template, and I want that to be created in the Web API folder inside of here. So we'll go ahead and run that. That's all fine. Let's shift to the Web API, and we'll go ahead and just do a .NET build, make sure everything's, and I know I can just do a build and it will do everything fine. So that's got, let's do a .NET run, and right, when that runs, that should give me an application. Let me make sure what that's not what I want. I really want to see. Okay, so this is going to 5267, right? So let's go ahead and copy that out, and we'll get up here and hit our local host. And because this is a Web API, there's really nothing to see there. So let's go and look. Because it's Web API, I can go hit Swagger. I can see I've got weather forecast. It's a basic weather forecast demo. Everyone's seen this probably a million times by now, right? So it's up and running. The app is running fine. It's, you know, basic .NET stuff. So let's go ahead and stop that. And now, what I want to do is now I want to start seeing how do I take this and how do I add this to Docker? How do I put this inside of a container? So it's great that I can run this and I can run this locally. Let me do one thing here. I'm gonna shift just so I keep ports the same. I'm gonna do check. Get my fingers to work right for me here. Yeah. Let's go ahead and discard everything. Discard those. Okay, so now we're right back to where we were. Only this time I'm at 5131. I just wanted to make sure that I didn't mess something up in the previous one, and that I have the right port numbers. Honestly, it doesn't matter for most of this, just muscle memory for some of my later commands. So that's the basic weather app. There's really nothing to it. You know, it's a very simplistic app. Single controller endpoint. Nothing magic there, right? So the next thing we want to do is we want to start adding Docker here. So I'm going to go into the root of the application folder. So not where get ignore, not where readme is. I'm going to go into Web API here, and I'm going to add a new file, and I'm going to call it Docker file. And the name here is important. So Docker does use convention for its file names. So you can override that. You can explicitly give it the name of a Docker file to run. Most people don't. Most people just stick with the convention. It saves them extra work on the command line when they go to actually build this thing. So I want to build a Docker file, and so first thing I'm going to do is I'm going to tell it where my image is coming from. I'm going to say, hey, I'm not going to start building on my own. I'm going to actually use a base image here, and I'm going to use .NET and actually just .NET, and this changed recently with .NET 7, I think. We're gonna do it as, we don't need to do that. Come on. Okay, so .NET 7, and then we're going to set a working directory, and we're going to set app as our working directory. Now, a couple things to note here. This .NET SDK can be both a Windows image or a Linux image. Because I'm running in macOS, it's going to be a Linux-based image. If you're running on Windows, you have the choice to run either in Windows mode if you have Hyper-V available for you, or you can run in Linux mode. And Linux images cannot run on the Windows side, and Windows images cannot run on the Linux side. So you have to make sure that when you're pulling down images from Docker, that you know whether that image supports Linux, whether it supports Windows, whether it supports Mac OS. Now in Mac OS, I also have Intel versus the Mac chips, Mac Silicon or Apple Silicon. So there are some different variations, and most of the major packages are going to support all of them, like the .NET SDK does. But you will find instances where, like SQL Server, those support Windows, right? If you want to run on Linux or Mac OS, there is a SQL Server variant image that you can run on Mac OS. But it's not the same as standard SQL Server. So we've told it what base image we want. We've told it what our base working directory is. Now what I want to do is I want to copy we're going to copy that CS proj, and I'm going to copy it to a source directory here on my local. So this is copying from my local file system into the container. And then I'm going to do a run .NET restore, and that's going to restore that the NuGet packages associated with that. And notice the only thing I copied over was the project file. I didn't copy over all the other source files. So if you think about that, the reason I do that is that, remember I told you that everything we do inside of here is building up a separate image, right? So this tells me, well, this is a base image, so that's got one number. Workdir, I don't think this actually creates a layer, but this file change here absolutely creates a new layer, and it's a layer that says, hey, I've got a file in a particular directory, and it has some specific file information in there, and that's a layer. And then I do this .NET restore, and that's a new layer. And now I'm going to copy, I'm going to do another copy, and I'm going to copy everything else from that local directory into that source directory. So now I've got a new layer that's got 50 other files in it, or however many it is for your application. And the reason this is important is when I'm doing development, these files are the ones, right? I'm going to write code in program CSS and weather forecast and all these other, and in my controllers. I'm going to be changing these as I do development. What I'm probably not going to change very often is that CS proj file, right? And especially the way the later .NET project files go, right? It's not, I don't reference all of the other individual files. I'm just referencing package references or framework properties, things like that. Like what do I depend upon? How do I want the framework configured? Do I want nulls or not nulls or implicit usings or some of the other properties I can set for the framework? But typically, outside of changing packages, this file doesn't change very often. So if I can isolate that in its own two layers, then those maybe will be more stable than typically the rest of your source code will be, which is constantly going to be undergoing a lot of changes, which means this layer of the container is going to get built and rebuilt and thrown away many, many times. Okay. So once we've copied the rest of the code over, I can do a run. So run is interesting. Run says execute this command inside of the container. So the next thing that runs up here, so previously I had .NET restore, so now I'm going to do a .NET publish, and oops, .NET publish, and I'm just going to take that same source CS proj from up here. I'm going to do it in release mode, and then I'm going to output that into a /app folder, right? So it's going to go right here in my working directory in the /app folder. And then at the very end, I'm going to add something called an entry point, and I'm going to give it what my executable is, and I'm going to give it, it's not quite that. I want that because I did this in a different target folder. I'm going to do out web API. There we go. So that's the last of that. So this is a very, very basic Docker file. So I've got my Docker file. Now I can go ahead and I can, where is my, things are getting buried on me. There we go. And now I can go ahead and do a .NET or a Docker build, and I can, this -t says tag this with a name C# web API. Now I can tag it with a name and with a version and with variants and all kinds of weird tags, or I could give it multiple tags, but I'm just doing this so that I can reference this particular image by a name rather than having to remember, oh, this is 357.829.7,000 and something, right? So this is just a shortcut. So this is allowing me to specifically tag that. And so when you're going and putting things up on Docker Hub, this is nice because I could tag this with a version number, and I could say, hey, this is Docker build for C# web API version 5.1. And then when I release Docker, when I release my 5.2 release of that object, I can have another image that goes up on Docker Hub. They'll both have the name C# web API, but they'll have different version numbers associated with them. So we'll take a look at that here in just a minute. So anyway, so we can see here we've got 1 of 6. We got that image. We had 2 of 6 was cached previously. So it looks like working dir did actually create a layer. 3 of 6, this was cached. This is new. And these are now new layers that it actually built, because notice it found these other 2 layers somewhere on my machine already. So, and then it finally created this final image for me which is now available. So if I go and I do a Docker images -A, now I've got my web sharp, or yeah, my C# web is there, 09A6, right? Tells me, wow, this is 845 megabytes. So that's quite large. So typically, you'll see most of my other images are measured in kilobytes or a couple of megabytes. 800 is actually quite a large image for many images. There are whole operating systems that are smaller than that in Docker images. So what can we do about that? How do we fix that? So let's first run this and make sure everything is running correctly. So I'm going to do that Docker run again, and I'm going to we said we were on 5131. Right? And you might be tempted to do, oops, right, to do this, and that will not work for you. And if I come out here to my localhost 5131, so this is a .NET thing that you have to keep in mind. So this can't be reached. There's no way to get to it. 5131 is not working. So why is that? Well, in my Docker file, I told it to do a release version. So when you're in .NET, you need to keep in mind how you publish this, how you built this image, and so that 5131 comes from that launch settings, right? So this is only relevant in my local development environment, right? This is not relevant, and this won't be applied inside the production environment. So you have to keep that in mind when you're writing these files. Is like, oh, if I'm doing this as a release, that's going to be a slightly different configuration. So in that case, let's go ahead and stop that Docker remove -f 609, and then let's do Docker run -dp, and we're going to slightly change this. We're going to make this back to 8080, assuming I killed that other getting started, which I think I did. So that's, port's already allocated. I didn't kill it already. What is running on 8080 containers? Let's just make sure 8080, that's running. Let's kill it. Okay. And let's kill this and restart it. I could have done a Docker start and just restarted that. There we go. So now let's try this and go back to port 80 here, and you'll see what, come on. Now it's going to make a liar out of me. What did I miss? Port 8080 exited. Nice. What did I misspell? Let's go back here. Out web API .dll does not exist. So let's go troubleshoot this and figure out what's going on here. If I look at my code, I probably spelled something wrong. Oh, yeah, this should have been out here. Save that. Let's kill this. Docker rm-f58a and Docker build C# rebuild that, and then notice, because the only thing that changed there was all the way down at the bottom here, most of this it was able to reuse most of those other cache layers. So now I should be able to do a Docker run, and now let's run this again, make sure everything is running okay. And reload this, and I'm still getting some error here. So rather than .NET, let's make sure I'm in the right spot here. Yeah, .NET out. Did I do something caps or not? I don't think so, but there's an easy way. We're just going to do this git checkout step. This is why I number my steps in my demos, because if I mistype something, yes, I know there's a file that's not what you think it should be. There we go. Oh, it was probably, it didn't like that slash on the out. So everything else is the same. So let's rebuild this now. Docker remove -f .1 do another build. Okay, that looks a lot better. And then now I should be able to reload this. And we're still failing. What am I missing? Is something else running that's not supposed to be? This is the problem. Sometimes you get so many copies of these images and things up here that you miss what's running. Those are all images. Show running container. So I don't even have. So something. Oh, that was. I only did a Docker build. So it helps. I actually did a run. There we go. And now we're back to. Hello. Oh. So Swagger, because we're in release mode, I have to do one more thing. So in my Swagger file, actually, no, this should be fine. It's just not, so normally Swagger wouldn't run in that release environment, and this would be commented out, and I wouldn't be able to use Swagger there, but I've already commented that out in this version, so I'm not quite sure. Let's make sure everything is running here correctly. So this is running in 8080. Something somewhere has gotten this where it's. No, it still thinks it's running the wrong image. Did I run the wrong command? Let's try one more time. Otherwise, Docker run, sharp, let's make sure my Docker file .NET Docker run. Just make sure my image is correct. That all looks fine. Docker run. Yeah, I'm thinking I'm getting some caching, so I'm going to go try. I'm getting some really weird caching behavior here. Yeah, I'm not sure what's going on there unless I didn't map some. No, okay, let's do this. Since this is running, that's fine. So we can see my application is up there. We'll just go on to the next step. Not sure what I missed here that is causing it not to run, because there's nothing in the logs that would indicate it's, yeah, there's something on the loopback interface that's causing a problem. Let's see if we can map through on 5,000. We'll delete this. Let's see if it somehow picked up 5,000, which it shouldn't have. The demo gods are definitely stepping in here tonight. Yeah, it's already in use. So, yeah, we're just going to chalk this up to the demo gods, and we will move on. It's not really important. We know what the app looks like, so hopefully we won't see that issue continue as we go further. Okay, so I've got an app, I've got my Docker file, it's working. One of the problems we have, though, is we're still pretty large in terms of our images. So I'm still at 845 megabytes on this thing, and it's not, you know, it doesn't look like it's getting much smaller than it was a few minutes ago. Even though I've done a couple of things that should have helped. So let's see if we can fix that. Let's see if we can change the behavior here a little bit. And let's do a couple of things. We're going to add another file, because if we go into that image, one of the problems that that we'll see if we come in, do I have a image here? I do. Oh, this image couldn't be created. Let's create this one more time. We're going to do it on board. What I wanted to do, so one of the nice things about this is it does allow me to hop into a terminal really quick, so I can kind of see what's going on. So I can actually go through and see, like, I've got these object directories, which has a bunch of junk in it that's not really needed for running the application. I've got these bin directories. I've got source code in here. I've got a lot of things inside this container, which I really don't want in my normal containers. So what I want to do instead is I'm going to go ahead and delete this one, remove that container. Is I want to create a new file, and we're going to call it .docker ignore. And we're going to tell it we do not want either the bin folder or the obj folder, and we'll go ahead and save that. And let's go ahead and rerun that web API, or actually, we want to, sorry, we want to FE, and then we want to rebuild that Docker build to use C#. And then let's look at those images again. And now I went from 845, which is the previous one you can see here. We're now down to 841, which is a little bit better, but I think we can still do a lot better. And the way we're going to do that is we're going to take advantage of a feature called multi-stage files. So multi-stage files basically say there's a lot of stuff in this SDK that I don't really need. It's only there for building .NET apps. But when I actually go to run the app, I don't need most of what's in there. So what if I were instead, we'll do all the way down to everything down here to release looks fine. And we're going to copy this. And so because I'm not going to have the source, I'm not going to keep the source. We're just going to do this, like that. Working dir is fine. Copy, and we're just going to move that into the root and publish. Something like that looks fine. And now we're going to build the runtime image. And this time we're going to take an image. So we created a bunch of layers and we stopped. So this was the last command. Said, hey, build, publish this application so that it's ready for deployment. So now I'm going to do a new one. Everyone. .NET ASP 7.0, and then we're going to do another worker. Yeah, so this is like starting a whole new chain of images that I'm going to build up. And I'm going to copy from my build environment into the app/out directory. So this first one, when we did this .NET publish, we published into the out directory, which is underneath app. So we're going to copy from that build environment here, which is this whole top half, and we're going to copy that into my local root directory, okay? And the root directory in this case is app, okay? Entry point is still the same as it was before, so a couple of line changes here. Let's go ahead and save that. Let's rebuild that image. And now when we take a look at those images, we can get, now we're down to 220 megs for that same thing. So this is one of those scenarios where you can have huge savings in terms of these images by thinking about what the environment is that you actually need to run versus maybe what you need to do to build, or you may have separate multiple iterations that you go through, with this last one being the only one that you care about, right? So the second stage is really the one that ultimately gets saved to disk. The others are temporarily created. They end up in a cache somewhere, as you probably saw earlier, right? But all of these are kind of internal, and then we start getting into these second stages, right? So this stage is really the one that gets built out and stored. Okay. So now I have that new stage, and again, let's see if we're gonna, the gods are completely against us still. Docker run DP. I got there's no reason that should not be working. I'm gonna make sure. Let me just do a quick Docker PS and make sure nothing else is running. What do I have? Those two shouldn't be interfering with anything. We already did Docker build. There we go. open that, and we should see. Nope, I'm not sure what my network is doing tonight, but it's just refusing. Something weird's going on with Docker. Lovely. Oh, no, I know what it is. This is the case because we did not put this. We moved that local. We moved that to the root. So let's try this again. And unfortunately, most of this goes pretty quickly. Okay, so now we're back. So that gets us down to, we've got a Docker ignore, we've got a multi-stage file. We've done quite a bit with this file to this point, and we could keep going. There's one of the capabilities, and I don't think we have time to get into the demo right now. So one of the other capabilities is the ability to do what is called creating a volume, and there are a couple of different ways that we can create volumes, but fundamentally volumes allow us, just like we mapped ports through from the local file system to the container file system, we can map directories through from our local system into the Docker container. And why that's important is if I change files inside that Docker container while it's running, and then I delete that container and create a new instance, I won't have access to those files. Those files will live inside that container and get deleted along with that container. So by creating volumes, what I can do is I can actually create a place on my local hard drive where when the container tries to write to that directory, it'll be redirected to a local file. And so that's a very important concept to understand. Go through the getting started documentation that is available on the Docker website, and that'll walk you through some examples on how to do different creating volumes. The other thing, the last thing I would leave you with is all of this is great for a single container. There's capability to have multi-container installations and executions so that you could actually have an app that has a database container and has a Redis cache container and has another container that runs your analytics and another container that runs your main application. So you can actually segment and isolate these into separate containers and then use a tool called Docker Compose to actually bind all of those containers and deploy all of those containers together. And that's the last step before you get to Kubernetes, which is a clustering service, effectively orchestration service for spinning up many containers, either as part of a single application or across multiple applications. And by breaking these out into individual services, database container, a Redis container, a caching service, and all of these different services, along with your app, it allows you to scale each one of those containers based on the load that container is seeing. And so Kubernetes is really the high-end enterprise service that then allows you access to manage Docker at scale. Okay, so with that, the last thing I want to open up the floor if there are any questions, if people have any questions or comments or anything that you'd like to ask. before we end. Thank you very much for attending, and I do appreciate bearing with me through a couple of those. I'm not quite sure what's going on in my local machine. I've been living in Docker all day today, so I probably should have done a reboot earlier. But overall, I think you get the idea. And thanks everyone for joining us tonight. I appreciate it. Back over to you, Sam.
Thanks, Joe. Just had a quick question for you. So aside from the demo glitch that you had earlier, any other gotchas you've experienced with Docker before?
Yeah, so one thing that is interesting, this rears its head on both Windows and on Mac, not on Linux, is that when you do the volume binding, so volume binding looks a little something like this, right? We create a volume, we give it a name, and then we'll bind that volume to a directory inside. When we do this, one of the things to keep in mind is that under the covers on both Mac and on Windows, there is actually a hidden virtual machine that is used by Docker to kind of isolate the local file system. So depending on how you're creating your bindings, you can have a situation where it doesn't look like the file is showing up locally, but in fact it's getting created inside that hidden virtual machine. So there's some tricks to work around to get at that. But other than that, most of it's pretty straightforward. They've done a really amazing job on that getting started, on the getting started app, and it's really, like, in a lot of places the getting started is not that great. Docker is one where it's phenomenal how much information is in getting started, and you can just walk through those demos in there. They'll cover everything and more of what I covered today, so it's really a good resource to use.
That it is. And I see a comment in the chat. Laura is saying thank you for such a thorough and informational presentation. And I also echo that sentiment as well. I've seen some other Docker presentations before, but you did an excellent job doing from a ground up explanation, breaking down the fundamentals. So job well done.
Thank you.
All right, let me take control back if I may. I just have a couple of wrap-up slides, and we're going to be discussing some resources related to the presentation for tonight. So first and foremost, the recording of the presentation will be edited and will be uploaded in a couple days. Feel free to subscribe to the channel and to get upload notifications. And if you take a look over in the chat window, I posted a few links that are directly related to this slide. So you'll see a link for the YouTube channel, as well as for my blog, where I'll be posting the tech events that we'll talk about in just a second. And again, encourage you to subscribe to that to get the updates. And then last but certainly not least, the feedback eval form, where we want to fill that out and get some constructive criticism and some compliments over to Joe. The link for that is also posted in chat. If you joined us midway through the presentation, we had a special offer from Manning.com, 35% off, and the discount code is MTPCLEC21. And as you might have guessed, the link for that is also in chat. So we always like to discuss some upcoming tech events, both in user groups as well as conferences. November 30th, which is going to be not this coming Wednesday, but the following Wednesday, is going to be the .NET study group. And we're currently meeting to discuss Azure. And the whole point of that group is basically to gather people around to study a specific topic. In this go around, we're doing the fundamentals of Azure. So if you're interested in learning the fundamentals of the Azure cloud, or you want to study for your AZ900 exam, I strongly encourage you to attend the group. On December 14th is the Azure Cleveland user group, and there we'll be talking about Active Directories, and that's the second Wednesday of every month. On December 15th, which is the third Thursday of December, that is the Greater Lansing User Group for .NET Developers. And on December 22nd will be the December meeting of this group, the Cleveland C# VB.NET User Group. As far as conferences, on December 3rd is SQL Saturday. And if you're not familiar with SQL Saturday, it is basically an all-day event of topics relating to data and specifically SQL Server. Chances are, if you're in application development, you are interacting with a database, so you should find a topic that is of interest to you. The meetings are going to be online, and it's free of charge to attend. And then January 10th through the 13th is Code Mash. That's going to be happening in person in Sandusky, Ohio. Huge conference. A lot of people from everywhere, a lot of developers, a lot of representatives from Microsoft, Linux, and other organizations are going to be present. So strongly urge you to register for that. Always like to discuss job openings and see who has job openings that are available. Tech Systems always has some jobs posted, but in addition, we always like to ask who's hiring and who's looking for work. Obviously, in person, this was much more interactive, but if you have any openings or if you're looking to get hired at a specific place, feel free to send me an email or make it known in chat. And then lastly, my contact information. My email, snasser@nistechnologies.com. You can also find me on Twitter @SamNasser. And my blog, where the tech events will be posted, is samnasser.blogspot.com. And then if you haven't already connected with me on LinkedIn, I invite you to do so at linkedin.com. And we see that Joe posted that Improving is always hiring, improving.com/careers. Thanks for posting that, Joe. And with that, thank you all for attending, and thanks again to Joe for presenting, and look forward to seeing you all next month. Good night, everyone.